Okay, we're going to start today's class with a warm-up to get you ready for the quiz today. So follow along with me. So the first problem, we're going to solve the following system by graphing. So we need to graph both lines and find the intersection point. So the first equation is already in slope-intercept form right here, so we don't have to change it. The equation below, the negative x plus 2y is equal to 6, we need to get y by itself to graph that. So I'm going to add x to both sides. So then 2y is equal to x plus 6. And then I need to divide by 2. So then y is equal to x over 2 is 1/2 x. 6 divided by 2 is 3. So I'm going to graph that line, and then I'll also graph the other line, y equals 3x minus 7. So on both of these, the first one, your slope is 1/2, and your y-intercept is 3. And on the second equation, your slope is 3, and your y-intercept is negative 7. So over on the graph, I'll graph this first line, the 1/2 x plus 3. We start with 3. So start with your y-intercept of 3. And then I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. I'm going to do that a few times because remember when we plot these points, when we do both lines, if we see one point plotted twice, that's going to be our solution. So that's our first line. And then the 3x minus 7, I got a y-intercept at negative 7, so down there in blue, and a slope of 3, so I go up 3 over 1, up 3 over 1. I'm going to keep doing that until I hit the other line right there. So I see that I plotted a point twice. That point is right there. So the solution to my system is the point 4, 5. That coordinate point, that's the intersection. Okay. So now with substitution, solving algebraically, we want to find an isolated equation. So in this number 2, we're going to draw that chart. We put the isolated equation on the left, so we already have one that's isolated, x equals y minus 11. And then the other equation on the right. So I'm writing this equation on the left because that's the one where I have a variable by itself. So now from here, I box the expression that isolated variable is equal to. And then since that's equal to x, I put a box around the x on the other side. So now I replace that x with the y minus 11. Make sure you use parentheses because you're going to have to distribute that minus sign. So now if I use distributive property, that's going to be a minus y and a plus 11, which equals 8. Combine like terms, 2y minus y is equal to y, so y plus 11 is 8. And then subtract 11 from both sides. 8 minus 11 is negative 3. So once you solve for that one variable on the right side, you're going to bring it back up into the box that we already put on the left. So x would equal negative 3 minus 11. So then x would be negative 14. So then we could write this as an ordered pair. Remember, x goes first, y goes second. So that's the intersection point of those two lines. Number 3, we do not have a variable isolated. So I'm going to pick one of these two equations that I feel should be the easier one to get isolated, and it's definitely the bottom one because you already have a coefficient of 1 in front of y. So if I subtract 2x from both sides, I can rewrite that bottom equation as y equals negative 2x plus 1. So now to the chart, that new isolated equation goes on the left, and the other equation, 3x minus 4y equals 51, goes on the right. So I'm going to box the isolated part, negative 2x plus 1, and box the y on the other side because that's what that box is equal to. So now rewrite it, 3x minus 4, but I need parentheses, negative 2x plus 1 is equal to 51. Distribute the negative 4, so negative 4 times negative 2 is a positive 8x, and then negative 4 times a positive 1 is negative 4, is equal to 51. 3x plus 8x, that's 11x, minus 4 is 51. So then add 4 to both sides. So 11x is equal to 55. And then when I divide by 11, your x is equal to 5. So now I'm going to go back up to the box. And y would equal a negative 2, parenthesis 5, that's what I'll multiply by the x value, plus 1. So negative 2 times 5 is negative 10, plus 1 is negative 9. So the ordered pair is going to be 5 comma negative 9. So the only difference between number 2 and 3 is that in number 3 you had to isolate the variable first before you can perform the substitution. Number 4, you're checking to see whether negative 6, 2 is a solution. So we're going to substitute that negative 6, 2 into each equation. So 4 times negative 6 minus 3 times 2 equals negative 18. And then the other equation, put in the negative 6, that's your x, plus 3 times 2 is equal to negative 12. So I'm just substituting the coordinate point into x and y, see if they both make these equations true. So 4 times negative 6 is negative 24. 3 times 2 is 6, so it's still minus 6, equals negative 18. And negative 24 minus 6 is negative 30, which equals negative 18, but that does not equal negative 18, so that's not on the line. Down here, negative 6 plus 6 is equal to negative 12. I don't think so, because you get 0 equals negative 12, which 0 does not equal negative 12. So this is another no. So although I got 2 no's, all right, it doesn't matter because one of them could have been no, and it's still not a solution. So on your quiz today, you're going to have to graph, you're going to have to do a substitution, and you're going to have to answer the question, is a point a solution to a system? So this was one way to do this. You could have also used substitution to solve this and to see if negative 6,2 was an answer, but that might have been a little bit longer because we could have just checked this part right here, and as soon as we got no, the problem's done. You didn't even have to check the second point. But I'd watch for that on your quiz today. Be careful with that. Use a calculator to substitute in your negatives to help you out. Good luck on your quiz. After the quiz, you can start on worksheet 4, which is your homework for Monday, and get that done. Have a good day.